Okay, so we're quickly going to review solving equations with variables on both sides, but we're going to kind of go through it kind of quickly because this is a review topic. So let's first look at this equation. So our goal is to get x by itself. We've got x's on both sides and we have constants on both sides. So we always want to first get all of the x's on one side. We do not want to move the constants first. You always want to move the x's first. So this is the type of equation where you have an option. You can either take the 2x and subtract it and move it over here, or you can take this negative 3x and do the opposite. We would add it to move it over here. So that is an option for you, but we're always going to look at if it's positive, we're going to subtract it. We're always going to do the opposite. If it's negative, we're going to add it. So in order for us to keep our numbers all positive, I am going to choose to add this 3x and move it over here. But again, you can choose what you want to do. You can either subtract the 2x or add the 3x over here, but we are going to combine the x's all together. So 2x and 3x together makes 5x. We're going to bring everything else down. Nothing else has changed yet. Bring the 1 down, that is gone now. So this is now a two-step equation. So again, our goal is to get x by itself. So at this point, we always want to undo the addition or subtraction right here. Okay, so since we are adding 6, we're going to do the opposite. We're going to subtract 6 from both sides, bring everything else down. The 5x has not changed. 1 minus 6 is negative 5. Okay, so now that's one of those two steps to get x by itself. Now the last step is 5 is being multiplied by x. So in order to get x by itself, we need to undo the multiplication. The opposite of multiplication is division. So we're going to divide by 5 on both sides, and that will give us x equals negative 1. And that is our answer. And remember, you can always take your answer and plug it back in right here for x and see if what you get on this side and what you get on this side does equal out to be the same. If it does, then you did your equation correctly. Okay, this second one, so anytime that you have parentheses, so we have a number on the outside of our parentheses, we're going to have to use distributive property. Okay, so distributive property is, remember, you're going to take whatever is on the outside and distribute that number to everything on the inside. So this 4 is going to be distributed to the 2a and to the positive 3. Over here, this negative 3, that whole entire thing goes together. The negative and the 3 go together. Negative 3 is going to get distributed to the a and the negative 1. Okay, so we're going to first distribute before we move any of the variables. So 4 times 2a is 8a. 4 times positive 3 is positive 12. It's positive 12, so we are going to include a plus sign in front. Equals, so negative 3 times a gives us negative 3a. And then negative 3 times negative 1 is positive 3. So we're going to add a plus sign in front there. And then we're going to include this as well, plus 31. Okay, so after you distribute, the next step is going to be to look for any like terms. Remember, when we combine like terms, we're looking for, let's say on this side of the equals, if there was any other variable with the letter a, we would combine them, but there's not. There's no other constant to be combined, so that stays there. On this side, we want to look for, are there any like terms? So there's no other variable of a to combine with this negative 3a, but we do have a plus 3 and a plus 31. So these two on this side of the equals need to be combined as our next step. So what we're going to do is we're going to rewrite everything over here as the same. None of that is changing yet. The negative 3a is still there. And now we're going to combine these like terms. Positive 3, positive 31. We're going to add them together to give us positive 34, or plus 34. Okay, at this point, now we are back where we started with this type of equation. So this is where you have an option. You can either move the 8a over to this side by subtracting, or you can move the negative 3a over to this side by adding. So I want to keep my numbers all positive, so I'm going to add 3a to this side. 8 plus 3 is 11. 11a, bring everything else down, the 12 plus 12 is still there, equals 34. Okay, again, in order to get a by itself, we want to undo the addition or subtraction next. So this was plus 12, so we're going to subtract 12 from both sides. Bring down the 11a, and then 34 minus 12 is 22. Okay, and then last step, 11 is being multiplied by a, so the opposite is to divide by 11 on both sides. So 22 divided by 11 is 2. So a is equal to 2. And again, you can plug it in and make sure your answer is correct if you want to do that as your last step. Okay, last one. So anytime you have a word problem, we want to do our marking the text. So remember, that is, we're going to circle the numbers, we're going to box any key terms, underline the question so that we don't miss any important information. So a town's population is 14,000, and it is increasing, this is a key word, increasing by 160 people every year. That's going to be important to us. And nearby town has a population of 24,000 and is decreasing, that's going to be important, decreasing by 200 every year. In about how many years will the populations of the towns be equal? Okay, so this right there, by reading that part of the question, that is going to tell you that you're going to have an equation with an equals in the middle. We want to know, okay, we want an expression for the first town, their population. We're going to have an expression for the population of the second town, and we want to know when will they be equal. So we're going to have an equal sign in the middle. So whenever you have a word problem, I boxed every year 2 times, because whatever number goes with that every year, that is going to be the number that's multiplied by the x, because that is happening repeatedly. Every single year, this town is increasing by 160 people. Every single year, this town is decreasing by 200. So that happens repeatedly, so that's the number that's going to go with your x, or your unknown. And then you're always going to have a starting point. This town starts at 14,000, and then again on the other town, this town starts at 24,000. Those are going to be your constants. Those do not go with the x, or your variable. So I'm going to start with the first town. So I'm going to write it like this. You can write it however you choose. I'm going to write it like this. They start out at 14,000, and it is increasing by 160 people every year. So they are increasing by 160 people every year. I'm going to use an X. You can use whatever letter you want. So every year they gain 160 people. So that's how it should be written. Okay, on the next town, they start with 24,000, and it is decreasing by 200 every year. So it is decreasing, subtracting 200 every year. Okay, so now you have a two-step, or a multi-step equation. We don't need to distribute, we don't need to combine like terms. What we need to do is that first step we're going to look at, we want to combine the x's, so you can either add the 200x over here, or you could subtract the 160x over here. I'm going to keep all my numbers positive, so I'm going to add the 200x over here, bring everything else down, 14,000. Then we have 160 plus 200, that gives us 360x. Bring everything else down, equals 24,000. None of that has changed yet. So again, this is your two-step equation, so you always want to undo the addition or subtraction first. Now, going back to what we did up here on these two problems, when we undid the addition or subtraction, we were moving the constant. Our last step is always going to be to divide at the end. So we're not going to subtract this. That is not the constant. We're going to, this is positive 14,000. We're going to subtract this positive 14,000 because that is the constant. It's just rewritten in where these two things are backwards as opposed to the other problem. So bring everything else down. 360x equals, now we've got 24,000 minus 14,000, which is 10,000. Move the constant, and then we divide to get our x by itself. So 360 is multiplied by x, so we need to undo it by dividing. Divide by 360 on both sides. So now x is by itself. So when we plug this into a calculator, we've got 10,000 divided by 360. All right, so it's not a perfect number, but we get about 27.7, or we can round up to the tenths, 27.8 years. 27.8 years.